We have a molecule ethane undergoing a homolytic fission. It breaks into two methyl radicals. The question is, this reaction is not found to be spontaneous, though one molecule gives two molecules, making delta S positive. We have one molecule and two product molecules, therefore the randomness increases, making delta S positive. But the reaction spontaneity is not given by the change in entropy only. The effect of delta S becomes almost negligible compared to the very high bond dissociation energy, that is the delta H for the reaction. The reaction is very highly endothermic because it involves breaking a strong carbon-carbon bond. Delta G is equal to delta H minus T delta S. In this reaction, we have a very highly positive delta H and we have a very small value given to delta S, which makes the second term very slightly negative. We are subtracting a very small amount from very high positive value, which will make delta G positive. If delta G for a reaction is positive, the reaction is non-spontaneous. Generally, delta is small compared to delta H. If we compare the two magnitudes, delta H is always higher than delta S. At ordinary temperatures, the term T delta S is not sufficiently high compared to delta H. So, at ordinary temperatures, T delta S can be ignored and the sign of delta G would depend only on the sign of delta H. That is, an endothermic reaction becomes non-spontaneous and an exothermic reaction becomes spontaneous if T delta S can be ignored. But at very high temperatures, we cannot ignore T delta S. We have to consider the effect of T delta S also.